Good afternoon, ladies and gentlemen. What'd you say?
Happy New Year.
Happy New Year. How about Happy Mother's Day?
Happy Mother's Day to all the mothers.
Did anybody celebrate Mother's Day with their moms yesterday? You did?
I celebrated with 3
Because
moms.
there's so many mothers in this class.
I'm a mother.
Well, the future mothers. The thing about it is,
Actually, I guess.
the thing about it is that if you think about it, and you may not think of it this way, but 10 years from now, a lot of you are going to be mothers.
Are you going to be mothers?
And
I will not. Yeah.
by the time you're 30, most of you will likely be mothers.
So it's more like Wednesday.
Pardon me?
It's more like Wednesday.
I'll be a baby in a year.
It's more like what?
Wednesday.
Women's Day? Yeah. Yeah. So, but if you really think about it, that's true. Okay. So anyway, on these what I do is I look for direction first, and then now your paper, on your paper you have a little bit different graphic than I do.
I don't want to do this.
And the reason you have a different graphic is that the one I have up here wasn't very copyable. Do you see where yours is a little bit darker than that?
Yeah.
I want to give you.
lines.
It has more lines too. So what you can do is, like, you have 6 rings going up here to the top, whereas I have 3. So you can just label every 2. You could put, like this would be 2 rings out, you can put 1, 4 rings out, you can put 2, and the very top you can put 3. So you come here to 4 pi over 3, and 4 pi over 3 is going to be right here. And so the radius of 3 is going to be right here. So basically, you're going to have this point right here is the plotted polar coordinate pair. And that's all there is to it.
Yeah, I don't understand.
You don't understand it? What is it? What don't you understand? Do you understand what 4 pi over 3 is?
Yes. Yes. Do you just look at it on your circle thing? Yeah.
You can. Now, if you look at it, some of these points may not be, I'm looking for what they are here. Yeah, some of these like 9 and 10 aren't standard unit circle numbers, are they? So if you can look for it instead, if you can't see what it is on the unit circle, what you need to do, the best way to do it is convert to degrees to then figure out about where you are, and then you can use that for direction. Okay. What I have on number 8, I believe, is very similar for degree of difficulty as number 7. Yeah, this should be very simple also, right? 5 pi over 6, 2. And to me, what I find, one of the hardest things I see on this is going to direction first. Because usually you think of x, y, you go to x and the y. Well, in polar coordinates, to me it makes more sense to look at the direction. And to me it helps to think about what we talked about last Friday was, what do you do in navigation? Well, you point a certain direction and go that way. And so that's what this is. You're going a certain direction. Now I want to show you this one here. 2 pi over 5. Is pi over 5 a standard unit circle thing? No, it's not. And so how are we going to handle this one?
Change it to degrees.
I would change it to degrees, exactly. So I go to 2 pi over 5. And what do we do to change this to degrees?
Something with pi in it.
Some with pi, yes. Multiply by,
Pi over 3.
no,
180 over 5.
180 over pi, thank you. Very good, good work.
Thank you.
Kaylee, that was excellent work. All right. So now we have is we're left with 360 over 5, which since I'm well rehearsed, this will be 72 degrees. So you can see about where that is, right? These increments are 10. So 30, 40, 50, 60, 72. So about right here. And it says -1. What does -1 mean?
Move in the other direction.
Yeah, moving the other direction. So we're going to go here and past it 1. So the thing's going to be about right here. Was it -1? Yeah, -1. So about right here is where that is going to be.
So the negative sign doesn't really matter?
Yeah, it really does, because if it's not -1, if it's +1, it would be up here. But -1 is the other direction.
But,
Wait a second, I got it wrong.
huh?
It's going to be over here. So you have 1 is over here. So if it's 1, your answer would be right here. But -1 means a radius of -1 means you go the other way 1.
So then how come?
So there it
Never
is.
mind. So the first number is how many circles?
Here's the radius.
That's right.
So, the first number is.
And then, if it's negative, it's gonna split the other one, so it's the
Yeah,
other side?
so when the radius is negative, it means you go another 180 degrees and draw it there.
Like -2. But it's just you follow it.
Okay.
One thing you could do is you could convert this to a positive radius. Like if you put 1,7 pi over 5, it'd be the same thing as here. But that's almost too much to explain.
So the number after the negative is how many rotations it does?
The number, what's that?
So like,
These are not rotations, that's radius. That's our radius. Now, of course, you watched the class video from Friday, right, Angel? So you already knew that, right?
yeah.
That's what we worked on Friday. Oh yeah, you borrow a calculator and got some extra stuff too.
When are you going to want us to start turning our calculators in?
That's a good question. Who asked the question? You did, okay. Man, that's a good question.
Next Monday?
For 180 over pi.
Today? Yeah, today.
Good job.
Are we going to turn?
Calculator,
Started turning
calculator,
calculator.
Mr. G, calculator.
Oh, sorry.
Thanks.
One thing at a time. I'll tell you, one thing at a time can get me. So there's one thing at a time that kind of bit me in the behind yesterday. We may just have calculators to the very end. It could be Monday. Could be a week from today.
Monday and a week from today are the same.
That's right. So that was, you're right. I was being redundant. Exactly. So you know, here, you notice my redundancy. That is good.
Yeah, I was like, what is he using me as the same day?
It shows you're paying attention. That's what it shows. It shows that what I'm saying is not being totally ignored. That's good. Okay, you have questions on some of these others?
Can you do number 10?
Yes, I can do number 10.
And 11. Wait.
Okay, 10, 17 pi over 10. Okay, I'm going to go and do what Will says. and convert to degrees, I multiply by 180 over pi.
It doesn't, so mark the spot.
So that cancels out. And 180 divided by 10, that's 18.
Yeah, exactly.
So 17 times 18 is what that is.
306.
Is that what it is?
Yeah.
306.
306 degrees. So I'll go over here to 306. Well, I know this is 360, and that's 300. So 306 is going to be something like right here. But so this will be, I'll call this 17 pi over 10 radians. But then we have negative 3, so that means we got to come all the way over here. And it's going to be on this side of the line. So it's going to be about up here, isn't it?
Yep.
Yeah, about here. And how can you tell if it's right? Your reference angle, right?
Yep.
Your reference angle is going to be what, 54? And here you got to have a reference angle of 54. So this is going to be your point right here. All right. Number 11, you look at number 11 too.
Well, it's easy.
Yeah, it's pretty easy. Yeah, number 11. Now here the angle is just degrees. So here's 30. Here's my radius of 2. So that's it. That's number 11 right there. No negative radius to complicate things, right? Yeah, that should be really easy. Yeah, and those are all standard angles too. They're all standard angles here except for problems 9 and 10.
Did you have any Oh, wait, wait. Yeah, we're sure, yes. There. Right there.
I'll give you some time to finish this up. We're going to start working on converting some polar coordinates to rectangular coordinates again. We'll have that too. Bless you. What we say?
Bless you.
Bless you. Bless you. You know where bless you came from?
From Jesus.
No, came back from the plague era. When people start coughing, they would be worried about them getting ready to die. And so they just said, bless you. And it just stuck with tradition.
Basically, don't die.
Yeah, basically don't die, please don't die.
This is G, I'm gonna go fill this up real quick.
Okay?
I'm sweating.
Okay, we're gonna get started on this today too. I don't know how far you get.
Oh! I don't want to do it.
I protest, I'm walking out.
Get back. No, take that back. Ow. I don't want this, Mr. G. Yes. I don't want it. I don't want it.
We have juniors that have senioritis, we think they're seniors.
Oh, no, we definitely do.
We definitely
do.
are.
No, it's true, they feel that
I'm
way.
skipping next Thursday.
Or this Thursday?
Next
Oh, next
Thursday, not this Thursday.
This Thursday, excuse me?
Yeah. And then next
What's this
Tuesday,
Thursday?
my birthday, and I'm not going to school.
No, come with it. So you're telling us we have to sing you happy birthday on Wednesday instead?
Sure.
Okay.
If you want to do that.
Tuesday, he does.
I have to go get my license renewed.
Oh, you do, okay. Yeah, I see that. I see here. You got
Big
you
one
set
eight.
up for
I'll be
Thursday.
illegal.
Yeah.
Fresh charges against me.
Oh man, I got another birthday coming up
Cheyenne
next
bit.
period.
Ryan.
Yeah, Cheyenne is gonna be on Thursday also.
Yep, we have the same birthday.
And then I got
But she's gonna be
Lexi,
here.
you got Lexi
But
on
she's
Friday.
here, I'm ready.
Okay, these ones here
Big one eight.
are gonna be,
Hey, you could legally leave your house.
I could
Oh,
do a lot of stuff. Basically. So you don't ask
please.
my parents to kill me because it's there.
Legally.
Still die.
Okay, these ones here starting with
Still die.
15.
Poor me.
On the school night.
Poor me.
Okay.
Like you want me to call idiot?
Okay, you juniors with senioritis.
What?
Okay, stick with me here.
Me, that's definitely.
What?
It's been a long, hard year.
No.
Stop now.
Do it.
Kaylee, just walk out.
It's okay.
Yeah, so
You
this-
can keep going.
So these are juniors with senioritis. They're juniors, but they think they're seniors, because they actually are very close to being seniors,
Yes, yes, we are.
like a week
Gosh,
away.
Mr.
from
G,
being
you
seniors.
can't, you're moving your cry.
You're gonna make me cry. Please make her cry.
Okay, so basically, what we have here is we have a formula for finding rectangular coordinates, which is, what's our formula for finding rectangular coordinates?
Rectangular coordinates.
X equals what?
X. R
Cosine.
cosine. And then Y equals R sine.
Sine is Y.
Okay, so you guys may be juniors with senioritis, but you do remember something. I give you credit for that.
We remember the song, that's it.
R
Well, good.
It's on the board, it's on the board.
And our sine is.
It's on the board, right? But, oh yeah, but if there's one thing you need to remember from this class, that I want you to remember from this class, that'd be this thing. Because really, if you look at it, this has been a thread going through the whole semester, hasn't it?
Yep. Yep.
And so if you don't remember anything more than this, you're still a long ways to figuring out how to do
It's like the last verse of
stuff.
our song.
Yeah. So it's kind of culminating.
I think you should play us the song today.
Yeah, if you want me to, I could do that. I want to play a Mother's Day song too, though.
Oh.
A Mother's Day
Yay!
song.
Do
I want to do
that.
that. I want to do that, the Mother's Day one off camera, though. I want to do that off camera.
What?
All right.
It doesn't matter.
All right.
You don't have to have
Anyway.
it graduate, but it doesn't matter.
Well, I guess I could do it on camera. Anyway,
We can send it to our moms.
okay. So R, what we have is, in this case, we have the radius is equal to 1.5,
No.
and cosine of that. Well, what's the cosine of 7 pi over 3? Is 7 pi over 3 a standard angle in your unit circle?
No,
No, it's not, right? But
Genius.
what is a rotation in a unit circle?
Pi over 3.
So what it's going to be, it's going to be 2 pi plus pi over 3.
Which is 60 degrees.
And so this is going to be like 360 plus 60 degrees, which is what, 420? It's like 420. And so what it is pi over 3 is not 7 pi over 3, but 7 pi over 3 is what compared to pi over 3. In fact, it's the one they give here. It's coterminal, right? So angles that are coterminal have same sine and cosine. So therefore, I know the cosine of pi over 3 is the same as the cosine of 7 pi over 3. And what's the cosine of pi over 3?
60.
Cosine of pi over 3.
Cosine?
3 over pi.
1 over square root 2.
1
I
over
thought it was
3.
1/2.
1/2.
Yeah.
Yeah.
Okay, yeah, square root of 1 over 2.
Yeah.
And what's the sign going to be?
Square root of 3 over 2.
Square root of 3 over 2. Does the hand trick confuse you?
Yes.
Only the sine part. How do you get it? Because I thought that was 3, not the sine.
Well, sine is this.
The bottom over 2 would then be 3 over 2? So it's the
Square root of 3 over 2 is your sine. Square root of 1 over 2 is your cosine.
Wait, square root of 1 over 2? Yeah, how do you get the square root of 1 over 2? 1 over 3?
No, it's over 2. It's all over 2.
Oh, it's always over 2. Okay. that's
Always
what we
over
did
2,
it.
yeah. It's, if you look at the units, look at Emma's unit circle, right? Everything's over 2.
Well, yeah, we were just confused.
No, that's fine, but you were here. If you weren't confused from time to time, would you need to have me as a teacher? No, you wouldn't. You wouldn't need me, right? So so sometimes when you have questions, it makes me feel like I'm needed.
Like you're hired.
Yeah, so, and what happens if you know everything?
Then you wouldn't get nowhere in life.
Then we're the teacher.
Then you're the teacher, then we'd have to move on to something else that you don't know, right? So not knowing everything. So we have is for this, we have cosine of pi, well that's going to be 1/2, right?
Yes.
So that's going to be 3/2 times 1/2, which is,
What is that?
3/4, okay? And for our sine theta, we have y equals 3/2 times square root of 3 over 2. And what's that going to be?
Okay, just kidding. Will's got it.
5.2. Yep.
Oh, I knew that.
3 square root of 3 over 4. So our coordinate pair is x is 3/4, y is 3 square root of 3 over 4. So that's our answer. Now, which ones, there are a couple ones here where you have to actually use a calculator to get a number. Which are the ones here where you actually need to use a calculator to get a number?
The ones that don't, like, aren't on the ones that aren't on the perfect.
The ones that aren't on the unit circle, which are
17 pi over 4.
17 and 8. 17, probably 17 and 18. 17 pi over 4, you can still use it because
I'm
it's
sorry.
over 4, right?
She didn't mean that. I didn't mean that.
The 7 over 4 will work because you can find an equivalent to that in unit circle, right? Same thing with pi over 6, pi over 2, pi.
So anything even.
Well,
Not
no,
necessarily.
not necessarily. What about over 14, right? Over 14 wouldn't be, they'd be even, but that wouldn't qualify. Same thing with over 12.
I still like to change the degrees because I understand that way easier.
Yeah, that's a good strategy, is changing to degrees and working with degrees. That's a good strategy for this. But part of what we're trying to do in this class is get you gradually more comfortable with working with radians.
You have any other unit circle chart?
You don't have one?
No.
Do you want one?
I don't know.
Yeah. What happens, people have been losing these, I printed up extras here. I got you one. Okay, what I want to do is, if you don't mind, can I show you 17?
Yeah.
Yeah.
And 16.
Now, in this case, you have a non-standard, I mean, it's totally non-standard. But what is 2 pi going to be in sevenths? How many sevenths are you going to have in 2 pi?
7.
14.
You have 14 sevenths. Who said 14? Here. 14 sevenths, yes. So 2 pi is equal to 14 sevenths pi. 14 pi over 7. So we can go ahead and rotate to a regular unit circle by adding 14 pi over 7. But to get an exact solution, is that going to help us? No, that's not going to help us. Now, you could convert to, Hannah may have already converted this to degrees. And if she wants to do that, that's fine. But we don't even have to do that. We can just keep it in radians and just use that. So x,
We're still on 16.
well, I'm on 17.
Well, we're not.
So
So.
-3, we can go back to 16 if need, okay?
Okay.
So we have this, and we can just plug in cosine of -29 pi over 7. And so that's going to be our x-coordinate. So -3 times, well, I got it up here already from 5th period. See that?
2.7.
So
Negative.
-2.703. Okay, you notice what units my calculator's in?
Rad.
Radians, okay? And then sine is going to be 1.302, right?
Yeah.
So this one here would be 1.302, and that's going to be y equals -3 sine -29 pi over 7. And really, the way I look at it, you really, by adding 14 pi over 7, you can get this thing in between 0 and 2 pi, but that's not going to be helpful to you anyway, so it's because it's not on the unit circle anyway, right?
Yeah.
So, to me, these ones going straight to the calculator, that's probably the best way to do this.
Got it.
So, answer we have is -2.703, comma, 1.302. And anyway, and then 18 is similar. You said you get a question about 16?
Yeah.
No, I understand now.
We just haven't finished it.
Yeah, so this one here,
We're going too fast.
this one here, it's like, how many fourths do we have in 2 pi? It was 8 pi over 4, right?
8.
1.14.
So you can do
So,
2 full laps and then go
yeah,
half more to get to 45.
yeah, huh? So I like Emma's imagery because she's talking about laps. That's really good to bring back. Remember in this class we talked about PVAng, right? Physical, verbal. Well, that's bring it to physical, so that's really good. So here, we're going to take this 17 pi over 4, and we're going to subtract from it 2 laps, as Emma says. And we subtract out 2 laps, or one, that's actually 1 lap, right? You subtract out 1 lap, you get 9 pi over 4, right?
So then you can subtract out another one.
So let's
and get
subtract out another
pi over
lap.
4.
And we get pi over 4, right?
Yeah. And then pi over 4 is 45 degrees.
Yeah, so then we know we have cosine is square root of
2 over 2.
2 over 2, and sine is
2 over 2.
square root of 2 over 2. Actually, that's sine and that's cosine, but it's the same thing, right?
Yeah, 1.7.
So we get, so we have is x is equal to 2.5. I'm going to write that in fraction 5/2 times square root of 2/2. So I'm going to get 5 square root of 2 over 4. And y is equal to 5 halves times square root of 2/2 equals 5 square root of 2 over 4. Where did I get 5 halves from?
Never mind. Where'd you get to?
Okay, I did it right. I did it, but I just left it like that and did it in cosine and sine, and I got 1.77, comma 1.8.
So you did it on the calculator is what you're saying? Okay, here you don't need a calculator. It says approximate the exact solution values with a calculator when appropriate. Well, it was definitely appropriate here, but here it wasn't needed because you could get exact values.
I just don't really understand it that way.
Okay.
Makes
Alright.
more sense the other way.
And then if you take, one way you can do is you can kind of check this. What is 5?
It's gotta have -3 on it. Because it wasn't clear.
Hang on a second. So, five times square root of 2, and we're going to divide that by 4. So yeah, you get 1.78. That's what you got, right?
Yeah.
Yeah. Which was this is your exact answer, but if you put decimals, I guess that's okay. Okay, we're going to do some, so you should be able to get close to that. If you don't finish it today, that's okay. You can work on it a little more tomorrow. Is that be all right? Let's keep that with you. The other class didn't quite finish here today. You finished it? Yep. All right.
Oh my gosh, you're so sweet.
I mean, the back is pretty simple, right?
Yeah, the back is easier. Really.
Alrighty? Oh, this is raining.
Okay, I want you to remember, I want you to sing as much as you remember about this. Zero, pi over 6 and 1. The next one to know is pi over 4 and pi over 3 and pi over 2 are all of the radians of ours circumference is pi times 2. 0, 30, 45, 60, 90. That's why I love units, circle trigonometry. 0, 30, 45, 60, 90. That's why I love units, circle trigonometry. The x's are 1 square root of 3 over 2 horizontal. They must be square root of 2 over 2. And next are 1/2 and 0, the stately x. Secretly they're cosine, but that's coming next. 0, 30, 45, 60, 90. That's why I love unit circle trigonometry. 0, 30, 45, 60, 90. That's why I love unit circle trigonometry. 0, 1/2 and square root of 2 over 2. That's what I'm telling you. Square root of 3 over 2 and 1. The sine is the height at any radian. The square root of 3 over 2 is 1. 0, 30, 45, 60, 90. That's why I love unit circle trigonometry. 0, 30, 45, 60, 90. That's why I love unit circle trigonometry. There are 3 other quadrants to the unit circle that is in your view. I'm not going to sing them, you can work them through. And while you are doing that, I'll say to you, and what I'm going to say to you, our cosine is x and our sine is y. That's why we love unit circle trigonometry. Our cosine is x and our sine is y. That's why we love unit circle trigonometry. Okay, you guys did a really good job of remembering, because I even paused for the height of the radian, and Will just came in there.
Yeah,
Well-
we're good.
Really good. Oh, that's, hilarious. No, but that's still good. I appreciate I appreciate that you're organized enough to keep those with you. Okay, did you enjoy Mother's Day yesterday? You celebrated Mother's Day?
Yes.
Okay, I'm sick to do a Mother's Day song.
Did you pause that?
I didn't pause it yet.
Oh.
Now, here's what it is. This is a song about a conversation with a baby who's about to be born and God.
Okay.
That's some good stuff right there.
Deep. Deep.
Okay. A little baby told God, hey, I'm kind of scared. I'm not sure I really want to go down there. Your head looks like a blue ball. It's a great big place, and I am so small. Can't I just stay here with you? Did I make you mad? Don't you want me to? But then God said, oh, but child, of course I do. But there's someone special who's waiting for you. Hush, little baby, don't you cry. 'Cause there's somebody waiting down there whose only golden life is making sure you're always gonna be alright. Loving angel, tender, tough and strong. It is almost time to go and watch you walk. And when she's talking to you, be sure to listen real close, because she's going to tell you everything you're gonna need to know. Like how to manage your liners, how to live and laugh and dream. And she'll set you on the path that'll lead you back to me. Hush, little baby, don't you cry. 'Cause there's somebody down on earth who's only all around. And making sure you're always gonna be alright. Loving angel, tender, tough and strong. To meet your mom.